when you are analyzing a polymer, the first activity is there that it is possible to deduce the repeat unit of a condensation polymer. In our memory, we have simple structures and we can find easily the repeat unit. But in the paper, they sometimes gives very complex structures and you need to find periodicity, which combination, which link is appearing again and again. So you have to copy the first activity.
I've copied it.
Now, take the example of condensation polymerization. These polymers contain, normally when we condense them, we take H from one unit and we take OH from the other. So we want to remove water. This is the main thing. For example, diamine and dicarboxylic acid or an amino carboxylic acid. So we can identify them. We can identify the repeat unit where we are getting the link after removing the water molecule. When a dioic acid and a diamine polymerize, a water molecule is expelled. Now OH is coming from acid and H is coming from the amine. When a dioyl acid and diamine are polymerized, a hydrochloric acid is expelled. This is unusual because the word condensation explicitly does not apply here, because normally when we use the word condensation, it means removal of water. But as I mentioned in the start of the class, dioyl chloride doesn't have any chance of giving you OH. Normal acid will give you OH and you can take H from the other, say amine, but here you will be having no OH. So you have to remove Cl. Definition is violated, but definition is still valid in our course. So these are the two examples where we can apply this. So you, after giving the heading, you have to copy this example first.
Okay. I've copied it.
Yes. Now you have to copy this example.
Okay. I've copied it.
Now, this is HCl. And now, second activity. You can see the arrow, so you can identify this is the second activity which can be given in the paper. Identify the monomer. Now they're interlinked. They can ask you to identify the repeat unit. Once you identify the repeat unit, then definitely between two repeat unit, there will be a monomer. So you can identify the monomer. Sometimes sometimes similar monomers are joined, and sometimes monomers are different. So identify the monomers present in a given section of a condensation polymer molecule. This is the second activity. You have to copy this.
Okay. I've copied it.
Good. Look at this. When a section of polymer is presented, the monomers can be identified by considering the small molecules expelled from the monomers. As I explained that if you identify if you identify the links, if you identify the repeat unit, you can easily identify the monomers. We will see this more when we are doing the past paper, because organic is now about to finish, and we can do past paper, and there we can see this polymerization. This is only a script. Now, why this script is needed? Because it can be asked in the paper that how you will identify the monomers, even though it's like a type of theory question. So you have to copy now this.
I've copied it.
Now, give the heading, predicting the type of polymerization.
Okay.
Now, what is this? This is again a type of interaction question. Predicting the type of polymerization. We have two polymerizations in our course. One is called addition polymerization, which is coming from AS. Second is called condensation polymerization, which is coming from our A2. So it is possible to predict the type of polymerization reaction for a given monomer or pair of monomers. Now, how we reduce the type of polymerization which produces a given section of a polymer molecule? They can give you monomers and they can ask you that is it going to be addition or it is going to be condensation. Now look at this case 1,2-dichloroethene. This is from AS. You can see that polychloroethene and the right side is repeating unit. The one is monomer. And how you are going to answer this question, they can ask you two things. What is the repeat unit and what is the monomer? In case of addition polymerization, situation is simple. The monomer will lose the double bond, the second pi bond, and monomer becomes the repeat unit. And the monomer repeats itself like the compartments of a train and it forms the polymer. So situation is very simple if you are doing addition polymerization. But when it comes to condensation polymerization, then it is difficult. So after giving the heading, you have to give side heading example one, and you have to copy this. This is addition polymerization.
Okay. I've copied it.
Now look at this second example, ethene and propene. We join them and this is our repeat unit. Repeat units can be identified here. And here the two monomers are different. One monomer is ethene and one monomer is propene. So these are the two monomers. We join the two monomers and if you see the second bracket, you will see a repetition. And if you are standing on the middle bracket and you can go up and you can go down also, this is called the repeating unit. This is called the repeating unit. Now, this is a table I will share with you so you can remember them. Even though table doesn't help in this chapter, in this topic, I'm sorry. But doing past paper will give you an idea what is the problem here. Actually, repetition can be generated from different molecules. The first one, this one is very simple because it's a repeating monomer. One monomer is repeating. Here there are two monomers and sometimes it can be a three monomer case which makes a pair a triplet and the triplet repeats. So this is a table. So you have to give a reference table. And I'm sharing it with you. You can copy it after the class. And I think I should give a reference number also onward because some students told me that he didn't copy the table or the image in time. And now it's a lost situation that what to copy where.
Here.
This is a problem. And I sorted it out because this is right. because if a student forgets to copy it immediately, everyone has other subjects, other things. So I have a pattern now that I will give you a reference number, you copy it there. And I
Okay.
put the reference number in the WhatsApp. So let's start this pattern here with chemistry here, this one. I'm marking it reference number 1. Okay, what you do? You write, give a side heading table and write under it reference number 1.
Okay.
Okay, this will be an idea. You leave around half a page. Now, what's the benefit of giving the reference number? You know, WhatsApp is always searchable. So when you write refer number, you can find refer number 1 after even time, and you can search what to copy here.
Okay.
Now, give a side heading identifying addition polymerization.
Okay.
Now look at this repeat unit, and you can identify this interesting past paper question where they are using C6H5. What is C6H5? Is it phenyl?
Yeah.
And it's a benzene link. So they have very carefully connected AS and A2. Addition polymerization is coming from AS, but C6H5 benzene link is actually coming from our A2. So you have to copy this example.
Okay. I've copied it.
Yes. Now, how we can judge that this is a polymer? Repeat unit is visible, but how we can say it is a case of addition polymer?
We can see that there's repeating units.
Repeating unit is always there. Repeating unit you will find in condensation also, but you can notice that the linkage between all the possible positions, there is no chance of removal of water or HCl. Because if water or HCl is removed, it can't be a CC bond directly.
Okay.
So this is an addition linkage. Now give the heading identifying condensation polymer.
Okay.
Now look at this.
Yeah.
Once you copy this, you can easily identify and you can feel the difference between addition and condensation linkages. Now you have to copy this.
Yes. So here we can see that the water molecule has been removed.
Yes, there is a high probability that there is a water molecule. Second, COO is a well-known ester link.
Yes.
You have copied it?
Yeah.
Now, heading is there, properties of polymers.
Okay.
This is a reference topic. These type of topics are open and they're not just like topics we were doing just before this one. They are just like for reference knowledge, properties and structures of polymers based on methods of formation, addition. Polymers are based on their method of formation, addition, or condensation. What's the meaning of what's the context of this topic? Actually, this topic has a background that why we go for such a big exercise and now why the polymer industry has grown so much, why we're making so many polymers starting from a small shopping bag till the bulletproof jackets and everything. Why polymer industry has grown so much? Why we make polymers? The answer is very interesting. We make polymers because we want to control the properties of material. Because we want to control the properties of material, we want to make a bulletproof jacket. Okay, now it should be a jacket and it should be a bulletproof. In its initial sense, when it was floated, the idea, the people thought this is not a sensible thing because something is bulletproof and something is a jacket. Jacket should be foldable, should be light in weight, should be wearable, but simultaneously it has to be bulletproof. Similarly, bulletproof glass. Similarly, a very interesting example which I have given many places and I got people know about it a lot. And you also have a, if you have a taste of using different versions of mobile, you must have seen those foldable mobiles now, which are foldable and you can
Yeah.
fold them, not those which have a hinge like a laptop or gadget, not that one, which are foldable on their screen and you can fold them like a paper. This is a very interesting property. You also have seen, you must have seen foldable glass frames, which we wear. They are highly foldable. So similarly, there is a many other example like artificial silk. Artificial silk is so strong that you can hold it to stop an aeroplane. You must have seen those strips which are on a aircraft carrier, and when a fighter jet lands, they stop it by that. They can stop it by it, and obviously a very huge inertia is there. So a lot of examples, never ending now. Lot of materials are needed. For example, you are making something and you are thinking to introduce some properties in real materials. There is a limitation for everything: density, mass, strength, viscosity, then a malleability, ductility. There is always a limit. So I repeat my concept. What are the concept of making polymers? Polymers are made to control the properties of a material. Okay, this is our main concept. That is why the place you are presently living, you will find a lot of research, lot of industries and refineries and other things, which are now talking about the petrochemical industry and pharma and other materials. Uh, Different drugs, pharmaceutical, different drugs are actually now polymers. And interestingly, the capsule which we use to take the medicine is also a plastic, but it is a digestible plastic. Interestingly, when this idea was floated first time, then obviously people were amazed. Digestible plastic. There are some there are some kids who might you have seen your in your own observation who eat paper. Kids can eat anything, obviously, but they can't digest everything. You have to invent a plastic which is digestible. That's very interesting. This is not possible in reality. So you need a polymer which can do that. So what is our concept? Polymers polymers are made like this. Okay, you have to copy this.
Okay. I've copied this.
Properties and structures of polymers are based on the methods of formation. This is my second concept in this article, that when you want to make a polymer and you want certain properties, you want to make a plastic. You want to make a plastic for making a bottle. That plastic should be hard. You want to make a plastic for shopping bags, and that should be soft. So you have to first decide that are you going to apply addition polymerization or condensation polymerization. So you have to copy this. This is the second concept.
Okay. I've copied it.
The presence of side chains and intermolecular forces affect the properties of polymeric materials. For example, spider silk. This is a very interesting discussion, and in our old syllabus, it was a topic. They take it out when the 2016 syllabus update was there. Why it is necessary to highlight these things? Because normally students go till 2012, and this is a good range from 2012 to 2023, which is around 10 to 11 years. Some people go beyond that. The second landmark comes on 2007 when syllabus got changed again, and then 2002. 2002 is obviously a very big journey, but there are people who can do that, who have done it. So 2002 was a major syllabus change. Then 2007, 2016, 2022, last year. Syllabus changes are should be well known, because obviously you have to follow the latest syllabus. Spider silk was in our course, but not now. But we need to know the idea that we can control the properties. Spider silk is famous. Once, obviously, it got the main fame because of the famous movie Spider-Man. The movie was definitely a fiction, but the idea was very interesting. that the spider silk was so strong that it can stop the train. Now, this is very interesting in science that they test the ideas, they project the ideas. Research is an ongoing process, and that is how they give actually support for new ideas in movies, interestingly, and also new ideas for people who are researching. When you, inshallah, go to a university where research is going on, you will see that these knowledge points are actually the starting point for new research. And they test it. And meanwhile, they are testing it, they give it open in discussion. And that's how movies are made. Spider make a silk, which is, we know, but it's not very strong. Normally it's very weak, and we can just like when we are cleaning, we can destroy it easily. But they open it because it's a protein structure. You can study a protein structure by electrophoresis. You can open the structure, you can break it down, and after breaking down the structure, you can separate the amino acids. You can see what is the chain. Now, by altering the chain, you can increase the strength. Once you get the code, how the strength is being there, you can increase the code. Once you get the code, you can increase the strength, and you can make a spider silk, which is available now, which is so strong, as I mentioned, it can even stop an aeroplane. This is called the concept of controlling the properties. Okay, so you have to copy this.
I've copied it.
The presence of side chain and intermolecular forces affect the properties of polymeric material like polyalkanes, PTFE, Teflon, Kevlar. These are famous polymers, and these are capable of changing the properties. Now, give a heading, degradable polymers.
Okay.
The concept now comes again, and it's a very interesting social discussion. Science and society is a very important topic, and if you must have heard about Einstein, the one of the biggest name in sciences, he made many discussions. And now in the world, if you join any field in the world of biosciences, which is related to human behavior, societies, you will find a big growth now. And obviously, the biggest portion which science has challenged is the environment, atmosphere. Now, WHO is warning. And again, I give the examples of movies because they are interesting and you can visualize things. And you must have seen in the latest, in the previous years, if you have a choice of watching these so-called science fiction movies, they are showing that our environment is badly damaging, and temperature of the world is increasing, and one day all of the world becomes water because water levels are rising, and a slight increase in water level, ocean level, can easily vanish the cities which are already under sea level. Now, how this story links here, because once science makes something, it's a research. What the people do after that, they make it a commercial activity. That is the place, that is the point where situation goes wrong. We made polymers to control things, but obviously science needs money for research and for development, R&D. Money cannot be provided for a long term. You can make a small polymer in a lab, but you can't make a polymer car in a lab. You don't have funds for that. They involve industries. When industries people come, they normally do not consider the environmental, social, human behaviors. Animal issues are obviously not a concern. We have destroyed majority of the animal systems in the world, and now their generations are instinct getting instinct. So they invented polymers by controlling their properties. One of the biggest desire was to invent polymers which are not deteriorated. For example, I want to store a cold drink in a can. So I would like that polymer, the can, should not be reacting with the cold drink. Otherwise, it can be a dangerous thing. Similarly, we invented polymers, shopping bags, so they do not react and we can store them for long period. This was a good thing, but that actually caused a huge problem, which you have seen many videos in the world, in the related to the world of severe pollution, water logging, environmental pollution, because we invented a type of demon, because these polymers never get destroyed because they are made to stay. We made them to stay. And when we made them to stay, after 30, 40 years, we come to know that we have created a huge problem, that the garbage of these polymers, how to destroy them. This is where science becomes very interesting. And when you make a research and you go in articles and you read, if you have a chance of attending, when you go abroad also, you will see that now people are talking about that these polymers have actually made our end of the earth very close. Why? Because these polymers are not degradable, not biodegradable, not any other way degradable. So they are there with us. And as they are there, we have to throw them. We throw them in water, we throw them under the earth. And now there are so many. Now, after such a big, huge loss, we made some interesting changes. Some of them are very funny and some of them are sensible. Very interesting, just for knowledge. There was a suggestion that why don't we put all of our garbage in the space? Why don't we put all of our garbage? Let's make a big ship, and it takes many rounds, and collect all the garbage on the earth and go and throw in the space. It is just like you are sitting in a car and you have a juice Tetra pack, and you, after drinking, you throw it out. What is your thinking? For example, I'm not saying you, I'm talking about a sense. So
Yeah.
if a person throws it out, it's a sense. He will think that's such a huge ground. What my juice will do, what my juice carton will do, it will do nothing. But many people, so that's why our seashores are badly polluted. So same we are doing that. Few years back, scientists thought about making degradable plastic. In many countries in the world now, non-degradable plastics are banned. Now they say make polymers which are degradable. So I gave you the whole background, connecting O-level GCSE chemistry, the famous pollution problems, burning of these polymers, and incineration, recycling, ground filling, reusing. There are many other, but none of them are now in here in our course. We have a concept of degradable plastic. So the concept is there. We invented polymers which are degradable biologically, chemically, or by any way. Okay. So we stop here. This is our heading. I gave the background and will inshallah continue in our next class. Thank you.
Thank you.